Hey everyone, this is your very last chapter of algebra, which is crazy. It's 8.1, so you should open up in your note packet, take some notes here. Today we're going to start our unit on radicals and square roots, which are essentially the same thing. But this is it, pals, this is it. So we are going to talk today about the basics. What are square roots? How do I simplify them? And then throughout the entire chapter we're going to do even more. So before we get started, anytime we're dealing with radicals and square roots, I want you to write your list of perfect squares. So do this now. I've written it for you. I don't know if you remember, but if you know your perfect squares up until 100, you are golden. So you can pause me if you need to. Get these in. You should know that 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. These are all of your perfect squares. Now, I do not expect you to memorize anything past 10 squared, so 100. But if you do, then your life is going to be a little bit easier. So you do need to know all these. Memorization should come with 1 through 10. Hope that makes sense. So get those down, pause me if you need to. But what does it mean to square something? Well, that's what we just did. When you square 1, that means you raise it to the second power, right? So let's write second power. That's what squaring something means. And that means just multiply by itself, right? 1 times 1, 2 times 2, 3 times 3, so on and so on. Okay, so that's what that means. Now we're going in the other direction. We're going backwards like we've been doing for a few chapters here. So this little symbol here, this is our radical symbol, our square root symbol. So now we'll go in the other direction. This is called square root. So the very opposite of a square, or the opposite of squaring something, is taking the square root, which is that crazy little symbol you see there. Okay? So now instead of doing 1 times 1 is 1, 2 times 2 is 4, now I'm going to start with the perfect square, as you see here. 16 is a perfect square. So the square root of 16, if I go backwards, 4. I don't know what that noise was. Sorry about that. All right, here, square root of 49. I'm going to look at my list of perfect squares. There it is. It's a perfect square. So the square root of 49, going the other direction, is just 7. Okay? So 7 times 7 equals 49, or 7 squared equals 49. Therefore, 49 is perfect. So if I take the square root of a perfect square, I get whatever it is that I squared originally. Does that make sense? I'm just going backwards. Easy as peas, easy peasy, easy as pie. You know what I mean. All right. So what we're going to do is now we're going to simplify things that are perfect. That's when life is good. And then we're also going to simplify things that are not perfect. Okay, the numbers here are perfect squares. Life was good. Life was easy. All right. So when they're not perfect squares, I'm going to come back to this in a minute. But I want you to notice something. 63. 63 is not on my blue list over here. So that's when things get a little bit more challenging, but that's what I'm here for. I'm going to teach you how to do it. That's what I do. All right, so 63, not on my list. So what I'm going to do is I'm going to look and see what is the biggest perfect square that I can divide by 63. So it can't be bigger than 63. So all of these options down here from 64 on, oh, that was a big little highlight. None of these are going to work because they're bigger than 63. Okay, so I'm going to ignore all of those and just focus on everything that's smaller than 63. All right, stick with me. So that means it could be 49, it could be 36, it could be 25, it could be 16, 9, 4, or 1. But I want the biggest perfect square I can divide by 63. So what you're literally going to do is you're going to go to your calculator. I don't know if you can see this over here. Let me move it. Okay, so I'm going to try 63 divided by 49. That doesn't work. So I'm going to try 63 divided by 36. That doesn't work. 63 divided by 25. I knew that. That's not going to work. 63 divided by 16. Oh, man. 63 divided by 9. Bingo. Got it. Okay? So 9 is the biggest perfect square you can divide by 63. So I'm going to write it like this. Oh, not like that. This is Stanford. Don't be a cray-cray. All right, I need my pen. So I'm going to do 9 is the perfect square times, nope, 7. So sorry. The square root of 9 times the square root of 7 equals the square root of 63. I'm just breaking it down because it's not perfect, okay? So I'm going to figure out what the square root of 9 is. Oh, that's on my list. The square root of 9 is just plain old 3. Okay? If it's perfect, it comes out just like we did up here. 16 was perfect, the answer was 4. 49 was perfect, the answer was 7. Okay? 9 is perfect, the answer is 3. 7 is not a perfect square, but it can't simplify anymore. So I'm going to leave it like that. Well, every time you're simplifying non-perfect radicals, one's going to come out, one's going to stay in. Here's how I remember it. If you're perfect, if you're a perfect child, your parents let you go out, hopefully. You're a good kid, right? If you screw up a lot, and you're not perfect, your parents probably ground you and make you stay home, like the 7. 7 is not perfect. It has to stay home. House arrest, right? So if it's perfect, it escapes. If it's not perfect, it stays underneath. Okay, so this is how you simplify non-perfect radicals. Okay, so the answer would be 3 square root of 7. Okay, let's do another one. 80, I'm going to look at my perfect square list and see if 80 is a perfect square. Don't think it is. It is not. I don't see it on my list. So I have to find the biggest perfect square I can divide by 80. So it can't be bigger than 80. So all of these past 81 can't work. It has to start with 64. So I'm going to go to my calculator again. I'm going to try 80 divided by 64. That doesn't work. 80 divided by 49. That doesn't work. 80 divided by 36. That doesn't work. 80 divided by 25? No. Okay, so sometimes it takes a while. 80 divided by 16? Bingo. Okay, so 16 is the biggest perfect square you can divide by 80. So I'm going to do this. I'm going to take 16 times square root of 5. Notice they're both still underneath. I'm still just simplifying. So the square root of 16 times the square root of 5 equals 80. 16 times 5 is 80. Okay? Now I'm going to look. Now one of these is perfect and can escape. It can leave the house. So the square root of 16 is 4. There's no square root of 5, so I'm going to leave that underneath, and that's my answer. Okay? All right, so I'm going to go back up here. Look for the largest perfect square. That's what you do first. That's what we just did down below. That can be divided by the number you're looking at. You're going to rewrite the numbers as radicals. Perfect square always goes first. 9 was my perfect square, so I did 9 times 7. 16 was my perfect square, so I did 16 times 5. Then you're going to find the square root of the perfect square. That comes out. Okay? Out. The other number stays in. Okay? So you're always going to have one out, one in. 26. I'm going to tell you right now, 26. So it can't be bigger than 26. You can't do 26 divided by 25. You can't do 26 divided by 16. You can't do 26 divided by 9. You can't do 26 divided by 4. So if none of those work, that means that this is already simplified. Love when that happens. Okay? Nothing else you can do to 26. I can do something to 50. This is the last one I'm going to do with you. So I'm going to find the biggest perfect square I can divide by 50. It can't be bigger than 50, so I'm going to start with 36. 50 divided by 36 does not work. 50 divided by 25? That does work. So I'm going to do 25 times 2 equals 50, right? 25 times 2 equals 50. 25 is perfect. Square root of 25 is 5. 2 is not perfect, so it's going to stay underneath. Okay, and that, my friend, is how you simplify radicals. I know that was a lot. You're going to get together with a partner. You're going to try some practice. You're just going to try your best. If you're confused, we will go through it tomorrow, but I'm just asking you to try it since I'm not there today. Thanks, guys.